Hello my dear students, in this session we will speak about some preluding about iron. Iron is a very important element in the heavy industry. Iron as an element has many chemical and physical properties that we can use in making a lot of things, so it is very important element. Indeed, it is the most famous element in the first transition series element. Copper and iron from the early days of human history used. So some quick character about the iron, and this prelude or introduction is an introduction to the iron, and afterward we will speak about the extraction of iron. The extraction of iron, we have to know a lot of things about iron first, then how we can deal with this iron as an iron ore, and then deal with it and make some chemical processes and some physical processes to make iron more suitable for human use or for the industrial use. Okay, this at the first we will see that iron here is its atomic number is 26, mass number 56 or 55.86. It is this 26 is the number of protons, and it equals the number of electrons in the neutral atom, and 56 or 55.86, it is the number of neutrons plus the number of protons. And then we have two common oxidation state here of iron. We all know that it is 26, so it is argon 4s2 and 3d6. So when it loses 2 electrons, it is argon 3d6. So positive 2 refers to the losing of 4s2 electrons. Okay, iron positive 3 losing 2 of the 4s2 electrons and 1 of the 3d6. So its composition or its electronic distribution of this iron positive 3 is argon and 3d5. It is more stable as the 3d's have failed in this case. Some chemical compounds, which I think all of us know it, with the atomic groups, in combination between the atomic groups and the iron. Iron may be positive 2 or positive 3. So in this case, carbonate can form ferrous carbonate or ferric carbonate, iron 2 carbonate or iron 3 carbonate, ferrous sulfate or ferric sulfate, or iron 2 sulfate and iron 3 sulfate, ferrous chloride or ferric chloride, iron 2 chloride, iron 3 chloride, the same name. We may name this compound ferrous oxide or iron 2 oxide, ferric oxide or iron 3 oxide, and this compound with the hydroxide group is named iron 2 hydroxide, or in the same time we can call it ferrous hydroxide or iron 2 hydroxide. Here ferric hydroxide or iron 3 hydroxide. The number here, the Latin number here, and all of these compounds refers to the oxidation state of iron. So if you have been asked, if you will be asked in the exam or in any question, that iron 2 sulfate, what is its oxidation state? It is 2. Iron 3 chloride, what is the oxidation state of iron? It is 3. So when you ask it iron 3 oxide, what is the oxidation state of iron? It is very easy. It is 3 here. It is the oxidation number of the oxidation state of iron. Look, when we have taken in the last year how to name the chemical compounds, we remember that the transition elements have more oxidation states, so we have to write the oxidation state of this element beside it like this. Iron 3 oxide means the oxidation state of iron here in this oxide is 3. Okay, what is iron element? Iron element from 5000 years BC. Okay, it is used and the Egyptians know it. So what is the ratio of iron? Iron is the fourth most abundant element in the earth's crust. The fourth most abundant element in the fourth crust after oxygen, silicon, aluminum, and iron come in the fourth place. So oxygen, nearly half of the Earth's crust of oxygen, 49.5% of oxygen. After that comes silicon, 25.7%, and after that comes aluminum, 7.5%, and after that comes iron with 5.1%. After iron come in the fifth place calcium with 3.4%, and all other metals 8.8%. So here what we are concerned here is iron. Iron as a metal come in the fourth place according to the abundance of the elements or the metals in the earth crust. Its percentage is 5.1% in by mass in the earth crust. Okay, so it cannot be found in the pure form in nature, but the most pure form here in nature is from the meteorites. Meteorites come from the outer space and hitting the earth surface. So meteorites, it's the ratio of iron in it is 90%. Other than that, it does not exceed 70% in all the ores of iron, as we will discuss afterward. Okay, so iron ores. What is the suitability of iron ores? We can not take the rocks of iron and use it in making the surgical tools, the electricity pylons, the reinforced concrete. We cannot make all these tools or all these metals or all these usages of iron directly from the rocks. Just grinding the rock and then make a paste from rock and make the iron as a tool. It is not appropriate and cannot be a practical way. So how can we use iron? We have first to purify iron from its ores and then make some or put some little amount of other elements to make alloys with iron and make these tools with it. So what is the suitability of the iron of the iron ores to extract iron from it? There are main three factors here. The three factors are the percentage of iron in the ore. If the iron percentage in the ore is high, so it is very suitable for us to extract iron from it. Then the composition of impurities. Okay, there are some impurities that we can deal with it very easy, and there is a lot of chemical ways to deal with these impurities and to get rid of it and make the iron pure. So the types of impurities is very important for the ore to decide, to make a decision for this or for us to extract iron from it or not. Okay, and also the other harmful elements mixed with the ore. So in some cases there is a very harmful elements. So if we have two ores, one of them with a very harmful impurities and the other with no harmful impurities, so when we extract iron with a more safety margin, so we choose to take the ores which have no harmful or poisonous impurities. Poisonous impurities here like sulfur, phosphorus, and arsenic. Okay, so let's have a look on these ores. The most important ores are four ores. These are the general ores of iron. One is the siderite. Siderite is ferrous carbonate or iron 2 carbonate. So its percentage is 30 to 42%. Okay, it is yellowish gray color. It is easily reduced. Okay, we will speak about first the composition of each ore, and there is some notes that you have to put into consideration because of the questions which come in the exam. there are some notes, very important notes about these ores. Okay, the first is iron carbonate, and its percentage is 30 to 42%. Here it is hydrated ferric oxide or hydrated iron 3 oxide. Its percentage is from 20 to 60 percent. Its color is yellow color. It is easily reduced. It is found in the oasis area. Okay. Afterward, hematite or ferric oxide. It is a dry ferric oxide. Here it is hydrated ferric oxide. There is molecules of water inside limonite as a composition. Here in hematite there is no water hydration or dehydration of water, or there is no water inside the composition of this ferric oxide, so it is easily reduced. It does not need to be roasted. It can be used easily without roasting in the reduction process or the extraction process. So here hematite is more easily to be reduced or used as an ore to extract iron from it than limonite. Limonite, we want more energy to get rid of these excess amount of water which exists in the composition of limonite. Okay, here the percentage of iron here is 50 to 60 percent. Its color is blood red. It is more easily reduced because there is no water of hydration inside its composition. Okay, it is found in the west side of Aswan and oasis area. Okay, magnetite, magnetic iron oxide. Its composition is mixture from ferrous oxide and ferric oxide, FeO and Fe2O3. So we'll speak about this afterward. The percentage of it is 45 to 70%. It has a black color. It has a magnetic property or properties. It exists in the eastern desert. So there are some notes we have to take into consideration because of the questions. Okay, the most frequently asked question. First, we have to notice that the siderite color, it is yellowish gray. It is not yellow. If it is yellow, then in this case it is a limonite. We know that also hematite is a reddish blood red or red in color, and magnetite is black. So we have to notice that the colors of each of the ores, of the iron ores. The first of them is siderite, yellowish gray. The second, limonite. You know that if you want to remember it, limonite is like the word lemon. Like the word lemon here, like the word lemon is a fruit, so its color, its ordinary color, its normal color is yellow. So limonite here also is yellow. Okay, hematite red, and magnetite is black. We have to notice another thing, which is ferrous carbonate contains coal, contains carbon, so it does not need to adding carbon to this ore. So when you ask that there is a certain ore that need not to add any coal in the furnaces to be reduced, so this is siderite. Another thing in siderite, we look here, all the percentages of the limonite, hematite, and magnetite can exceed 50%. Here it does not exceed 50%. So when it is mentioned in the example in the question that there is an iron ore which cannot exceed 50%, so it is 100% siderite. Okay, so another thing from the notices about these ores are the magnetic property or the strong magnetic properties of the magnetite. Black iron oxide or magnetic iron oxide. Magnetic iron oxide as an ore has a magnetic property. So when it is mentioned that what is this ore that contains or includes or has a property of a very strong magnetic character, so in this case it is magnetite for 100%. Okay, It is a magnetite that has a strong magnetic property. So we have to take into consideration these all notices because it is very important in the exam. Okay, let's look about these questions. The rock in the opposite figure is known as, and this is a rock. It is nearly, this rock is nearly black and has a strong magnetic property. It attracts the iron objects to it. So we have mentioned that the magnetite is the only ore that has a magnetic property. Afterward, another question. One of the iron ores does not require fuel. So it is siderite, as we mentioned before. It is no, it does not need fuel to during the rusting process. There is a rusting process, but we do not need a fuel of carbon because it is found in the layers of carbon itself. So here, look, this is limonite, this is magnetic iron oxide, and this is ferric oxide or hematite. The only one who contain in its structure a carbon is ferrous carbonate or siderite. Okay, let's complete the question. Upon its preparation to be loaded to the blast furnace we will explain afterward, as it is found basically between the layers of coal. Layers of coal means in its composition there is a carbon, it is a siderite. Okay, the percentage of iron in this ore does not exceed 50%, so it is siderite. Remember, it is siderite. It does not the iron in it does not exceed 50%. Okay, it is siderite also. What is the chemical formula of this? It is ferrous carbonate or siderite. Let's have another example. What is the chemical formula of pyrite? Here, this is magnetic iron oxide. This is hematite or ferric 3 oxide or ferric oxide or iron 3 oxide. This is ferrous carbonate or siderite. So we do not take this. And this is pyrite. Pyrite FeS2. And this is the correct answer. At this point, we finish our session. And God willing, we'll speak today about the extraction of iron. We'll take all the extraction of iron processes, God willing, this day. Thanks.